Have you ever wondered why an AI like GPT can write a rhyming poem with vivid imagery? Is it really understanding the meaning of poetry, or is it just playing an enormous, incredibly sophisticated word puzzle? Today, we're going to unpack this AI poet's brain step by step, from neural networks to GPT's core mechanics. The ability of AI to write poetry is built on deep learning, especially recurrent neural networks and their variants. Unlike traditional programs that rely on preset rules, neural networks mimic the way neurons in the human brain work, learning language patterns directly from massive amounts of data. This allows AI to capture the subtle linguistic patterns and imagery connections found in poetry. Imagine your brain with hundreds of billions of neurons, each a tiny computation unit. An artificial neural network borrows this idea, but instead of biology, it's made up of mathematical formulas. The smallest unit is an artificial neuron, which takes a bunch of numbers, multiplies them by weights, adds a bias, and passes the result through an activation function to decide the output. Neurons are layered as input layer to hidden layers to output layer. Hidden layers extract features, and the deeper the network, the more complex the patterns it can capture. Training is the process of constantly adjusting these weights so that the outputs get closer to the desired results. This is done through backpropagation, a mathematical optimization process. But neural networks only process numbers, so what about text? We first convert words into numbers called vectors using word embedding techniques. These map words into a multi-dimensional vector space where words with similar meanings are positioned close together. For example, take the vector for king, subtract the male attribute to get the core idea, rulership. Then add the female attribute. This points to the vector for queen. This shows how mathematical space can capture relationships between words. Two classic embedding methods are word-to-vec and glove. Word-to-vec learns word vectors by predicting context, while glove combines global statistical information to better capture frequent poetic pairings. Think of it this way. How do you make a computer know that apple and pear are similar, but both are very different from laptop? Both methods draw a coordinate map for words, but in different ways. Word-to-vec is like a local observer, learning coordinates by looking at each word's neighbors in short text. It has two main approaches. See bao, given, chasing in the sentence. The cat is chasing the mouse. The model guesses its neighbors. Cat is mouse. Over time, it learns that chasing often appears with cat and mouse, while eat appears with food or apple, so the coordinates for chasing and eat end up far apart. Skip gram. The reverse given neighbors, cat is mouse. Guess the missing word chasing. After lots of practice, the model learns cat and mouse often appear around chasing, so they're positioned close in the coordinate space. Glove, on the other hand, is like a global statistician. It counts how often two words appear together in the entire dataset. For example, in a huge poetry corpus, moon and sun might co-occur 100 times, but moon and computer only once. It turns these co-occurrence counts into numerical patterns, then maps the coordinates. Words that appear together often are placed closer. This lets glove catch semantic relationships even for words that don't appear in the same sentence but share meaning across the language. Now, poetry isn't just about individual words, it's sequential text, where later lines depend on earlier ones. Early AI used RNNs for sequences, but they struggled with long-range dependencies. They just forgot things too far back. The solution is the attention mechanism, a key idea in modern AI inspired by human focus. When we read, we naturally pay more attention to the important parts and ignore irrelevant details. In simple terms, attention teaches AI to look with priorities, giving more weight to important information and less to unimportant parts. The core idea of attention is to calculate weights. Scoring relevance. Each token is scored for how related it is to the current task. Normalizing into weights. Convert these scores so they sum to 1. Higher weights mean stronger focus. Weighted sum. Combine token information according to these weights, so important parts influence the output more. When handling long text, self-attention is used. This is the basis of the transformer architecture, which can process an entire text sequence at once, more efficiently than RNNs. GPT is a variant of transformer that uses only the decoder part, focusing purely on generation rather than input-output matching. Its training goal is simple: predict the next word. GPT's power in poetry comes from its pre-training, fine-tuning approach, and autoregressive generation. Pre-training, like a massive language bootcamp, GPT reads billions of text snippets, books, websites, poems, etc., and learns general language rules by predicting the next word. For example, given rough winds to shake the darling buds of, GPT learns to predict May, just like Shakespeare's Sonnet 18. Fine-tuning. After pre-training, GPT is refined on smaller datasets, say, only Shakespearean sonnets, so it learns specific poetic structures and styles. Autoregressive generation. Starting from the first word or line, GPT predicts the next word based on everything it has already generated, building the poem step by step. For example, give a prompt, write a Shakespeare-style sonnet about spring in iambic pentameter. First line, the model starts with, "From winter's grip when spring doth break its chain," using pre-trained knowledge of spring versus winter and fine-tuned meter. Second line, it uses the first line to choose a rhyming word, chain, and continues the spring theme, and buds, unbound, their tender heads attain, rhymes with chain, follows iambic rhythm. Third line, builds on buds and spring with related imagery. The zephyr sighs where roses soon shall blow, uses alliteration, a style learned during fine-tuning. Step by step, the model ensures rhyme, meter, and theme consistency until you end up with a poem that feels like it understands you. In reality, AI isn't feeling the poetry, it's using mathematics. Huge datasets and probability to pick words that best fit the given context. But that doesn't stop it from producing lines that move us. Alright, that's all for this episode's analysis of the principles behind AI's ability to write poetry. If you enjoy deep dives into computer science like this, make sure to subscribe. I've got more amazing tech stories coming your way next time.